Okay, today we continue to look into the motion with a constant velocity. And first of all, what is actually, when I say constant velocity, what does it mean?
Does it?
Yes.
Is it like it's just like this? The rate stays like the speed stays the same, it doesn't change up and down. No.
Yeah, any other attempt to define it? Okay, constant velocity means that displacement, if you look on the displacement over any two equal time period will be the same. So if you look the displacement over the first second, third second, fifth second, it will be the same. If you will take what the displacement over the first 0.1 second, over the time interval from 1.5 to 1.6 second, it will be the same. So over same time period will be same displacement. What does it mean? Constant velocity. Now, how we can graph it? And first, graph of the velocity against time. Velocity against time. If it's constant velocity, how this graph looks like?
They'll be straight.
Not just straight, horizontal line.
Yeah.
So let's say this is velocity in meters per second. So it will be 3 meters per second. What does it mean if I draw this line -5? What does it mean? Yes,
What's that thing below the V?
these 3.
Up the roof.
3 meters per second.
-5 meters per
What does it mean negative?
Going away.
Going into the negative direction with velocity 5 meters per second. Now let's recall the equation of the motion. Equation of the motion, x position equal initial position plus vt. So let's say initial position is 0 and 0, saying 0 right in screen. Initial position is 0 and velocity equal 3 meters per second. So if we sketch this graph, x against position against time, it will be a straight line, and let's say in 2 seconds it will be 6 meters, seconds, 1 meter will be 3 seconds, and so on. That will be graph representing motion of the object with the velocity 3 meters per second. Make sense? Now let's consider if motion is with the initial position is 20 meters. So it not start from the origin, and velocity will be equal -5 meters per second. The graph then will looks starting from 20, that's position against time in seconds and position in meters, and that's how the graph looks like, where this will be at what time position will become 0?
4.
4. At 4 seconds becomes 0. And that it passes the origin and continue to move in the negative direction. So that's how we graph motion with a constant velocity. Can you see from that angle? Yeah? Okay. Any questions about the graph? Okay, now let's consider the next example. Composite motion. If we have, let's say, we are in a bus. We are in a bus. And bus moving that direction with a velocity 20 meters per second. What it will be in kilometers per hour? 20 meters per second. Yeah, times 72 kilometers, 20 times 3.6, 72 kilometers per hour. And we move in that direction. And I will throw a ball with a velocity of 10 meters per second relative to the bus in the opposite direction.
Wow.
What will be the velocity of the ball relative to the ground? Remember, bus moving 20 meters per second that direction. And I'm throwing ball 10 meters per second in the opposite direction.
So that's negative 10?
No.
No.
How can you have a negative?
20 minus 10, 10 meters per second. Now he throw with the same 10 meters per second this way.
Oh.
What is the ball? What is the velocity of the ball when relative to the earth?
0.
Yeah,
Go
yeah,
back.
yeah.
30. We have bus moving that way and ball relative to the bus moving 10 meters per second. So what will be speed relative to the earth? 30 meters per second.
What were your teachers, like student versus teachers basketball games?
Yeah, you should apply it.
No, first of all, it was, if it will be a different time maybe, but my timetable was not allowed in that day. Now, does that make sense?
Yes, go.
Now let's consider the next situation. If we have a boat on the river, so we have a river with and there is a flow of the water, river, and the flow of the water this way, u with a speed, let's say
16.
3 meters per second.
With 13 off.
And there is a board.
Where are we?
There is a board moving this way with a velocity relative to the water 5 meters per second. What will be the velocity of the boat relative to the banks of the river? Will be in this direction, we'll have v plus u equals 8 meters per second.
What's U?
What's you?
U is the speed of the flow of the
Is that
river.
just a random?
Usually, if you need two velocities in the one question, usually we use v for one and often u for another.
But you and V look the same, so it might be cool.
No.
Now, but if we have now boat moving in the opposite direction against flow relative to the water, again 5 meters per second. What will be the speed of the boat relative to the banks of the river? Will be 2, not negative.
2 left.
Sorry, will be yes, negative. If you take this direction as positive, then will be u minus v equal negative 2 meters per second. Does it make sense?
So wait,
Yes.
so U is the speed of the water.
U is the speed of the water.
Okay.
V is the speed of the boat relative to the water. That's pretty much all about the motion with the constant velocity, and now we'll start solving the problems. Please
So good.
like, subscribe, and donate using the link in the description to help to fight the Russian fascists.
Start with-